We are now moving into a new unit where we are going to be looking at exponents and radicals, or sometimes known as square roots. So first of all, let's kind of talk about what an exponent does. You don't need to write this part down, just as a reminder. So if I have 5 and I raise it to the second power, that really means 5 times 5. So it's multiplying by itself, which is 25. If I had 2 and I raised it to the third power, that means 2 times 2 times 2. So the power basically tells us how many times we multiply it, okay? So what we're going to be looking at is properties of exponents, because we're going to be looking at variables with exponents and numbers with exponents. And when we have multiple exponents, it helps to have some rules to know how to simplify. So our first property is, again, this is a little bit confusing because we have multiple variables, but what we'll do is we'll look at the properties, and then from there, we'll create some examples so we know how to use them. So what this essentially means is if you have a same base raised to an exponent and you're multiplying those exponents, what you really do is add them. So what you do is you would take those exponents and add them together, okay? The reason why this works, let's look at an example. If I have x squared times x to the fourth, x squared means x times x, and x to the fourth means x times x times x times x. Now, how many x's is that? Let's count. 1, 2, 3, 4, 5, 6. So another way we could write this is just x to the 6. Now, that's pretty annoying to draw out those x's every time. So that's why we know that if they're the same base, you can just add them. So if I have x cubed times x to the fifth, I know that that's 3 x's and 5 x's, so I can just write x to the 8th, okay? So that's our first property, and so I'm going to highlight it so it stands out. Okay, our next one. So if we have the same base and we're dividing, what we really do is subtract the exponents, like so. And again, I'm going to highlight these properties just so they stand out. So let's go ahead and look at an example of that. So I'm going to use the x's once again. So let's say I have like x to the fifth over x cubed, okay? So in that case, I have 5 x's, 3, 4, 5, and on the bottom, I have 3 x's. Now, because there's x's on the top and the bottom, I can cancel, cancel, and cancel. So I'm left with just 2 x's, or I can write x squared. Now, an easier way of doing that would have been to just do 5 minus 3, like the property says. So let's look at another example. If I have x to the 7th over x to the 4th, I know that that's 7 x's over 4 x's, but I'm just going to subtract them. So 7 minus 4 is 3. Okay, so our next property is if we have a base and then we have an exponent raised to another exponent. So what we do in this case is actually just multiply. So it'd just be x times, or x raised to the power of mn. So I will highlight that. And I'm going to kind of stop showing us how it works with the x's. I know it's kind of interesting for the first few, but just for the sake of time, we'll just kind of do some examples. So if I have x raised to the 5th power, and I raise that to the 2nd power, I will get x to the 5 times 2, which is x to the 10th. And just so you are aware, what this is really doing is it's taking x 5 times, right? And then we want to raise that squared, so then we have to multiply x to the 5th times x to the 5th. So then it's just x to the 10th. Okay, for the next property. This one, if you have 2 variables or 2 numbers inside with an exponent, What that means is you actually have to distribute the exponent to both parts, like so. So I will distribute it to both the x and the y. So let's go ahead and try an example of this one. So if I have x, y, all to the third power, I'm going to make it x to the third and y to the third. So notice I distributed that cube to both parts. Let's try another example. If I have 2x squared squared. So that one's kind of combining a few different properties. So I know that I have to distribute this exponent to both parts. So it's going to be 2 squared, which would be 4. And then it's going to be x squared squared. Well, I just learned that if you have an exponent and you raise it to an exponent, you multiply them. So then it would be x to the fourth power. All right, looking at our fifth property. So if I am dividing and I have an exponent on the outside like that, it's kind of the same as the last. We just need to distribute that exponent to both parts. And the reason we have to do that is because of those parentheses, okay? So let's go ahead and look at an example of this one, or a few examples. So let's say I have x over y squared, and all of that is to the fifth power. So what I want to do is distribute that 5 to both parts. So it would become x to the fifth power, and it would become y to the 10th power. Let's look at another one. So if I have 3 over x cubed, and then all of this cubed. So I want to do 3 cubed. Well, 3 cubed is 3 times 3 times 3. So that would give us 27. And then I would have x cubed cubed. And so I know when I raise an exponent to an exponent, I multiply them. So this would become x to the 9th. Okay? This next property is probably your easiest one. Anything, any number, any variable to the 0 power is just 1. So that one's a pretty easy one. So an example of that could be if I have 500 to the 0 power, it's just 1. Okay? Now looking at the next one. So this one says x to the negative m. So this one's kind of weird, but what we have to do is we don't want negative exponents. It's like a bad thing in mathematics. So what we want to do to make this positive is we're actually going to rewrite it as 1 over x to the m. And the reason why I'm doing 1 is because technically there's a magic 1 or an invisible 1 right in front of that. So I'm going to go ahead and highlight this. So let's do an example of that because that's definitely a little bit confusing. So if I have x to the negative 7th, that goes against the rules. So what we want to do is rewrite this as 1 over x to the positive 7th. Okay, let's go ahead and try another one. If I have 2x to the negative 3, so keep in mind that the 2 is not affected by that negative 3, only the x is. So when we rewrite this, we would get 2 over x to the positive 3. Okay, so our next thing we're going to be doing is just kind of combining all of the properties. So I have quite a few examples here, and we're just combining all of the properties together. So it's just practicing. So our first one, and this should actually be a negative 3. So our first one, we have an exponent or a variable with an exponent raised to an exponent. So I know I just multiply them. So I would get x to the negative 12th because 4 times negative 3. And I'm almost done, but I know I can't have a negative exponent. So I'm going to rewrite it as 1 over x to the positive 12. And now that is okay. So then that would be my answer. Okay, looking at the next one. So I'm going to go ahead and put a 1 here. So when I have something like this, I like to multiply the numbers first. So I have 1 times 2, which is 2. And then I have m to the 4th and m to the negative 3. Now, I know that when I'm multiplying exponents, I really add them. So 4 minus 3 would just be 1. So 2m to the 1, and I can really just write that as 2 to the m because I don't need that 1, okay? Looking at the next one. So I am going to go ahead and multiply the numbers. So a common mistake is a lot of people get the exponent rules messed up with what we do with numbers. And so because we add the exponents when we multiply them, some people would say, oh no, that's 6, because 4 plus 2 is 6. Well, the numbers are still numbers, so we still multiply them. So 4 times 2 is 8, and then n to the 4th and n to the 5th. Now I would have n to the 9th. Okay, because now I have 9 n's. All right, look at the next one. It's got a lot going on. So the first thing I do is multiply my numbers. So 2 times 2 is 4. And then I have x cubed and x to the negative 1. So I'm going to add those together. So 3 minus 1 would give me 2. So I'd get x squared. And then I have y to the negative 3 and y to the positive 3. When I add those together, I get y to the 0. Now, remember, we learned that y to the 0 is actually just 1. So it's 4x squared times 1, which is just 4x squared. So 4x squared would be my final answer. Looking at the next one. So I'm going to put my 1 here just to kind of help me out. So it's just 4 times 1, which is 4. Then I have v cubed times v. So I know that technically there's a little 1 there. So v cubed and v to the first would be v to the 4th. And then I just have a u squared, and there's nothing to multiply it, so that just stays the same. So that one was actually pretty easy. All right, looking at this next one. So I know I want to distribute that exponent to both parts. So I'd have 4 squared, which is 16, and I'd have a cubed squared. So I multiply those exponents, and I get a to the 6. So our final answer would be 16a to the 6th. All right, the next one. So this one is a little bit tricky because you can kind of do it in multiple ways. I'm going to just go ahead and distribute that exponent to each part. So I'd have 4 to the negative 1, x to the negative 1, y to the negative 1. Now, there's a major problem here because we can't have negative exponents, right? So in order to make them positive, I'm going to take the number, which technically there is none, so I'm going to use 1, and this would become 4 to the positive 1, x to the positive 1, and y to the 1. Now I don't really need those 1s, so I'm just going to write this 1 over 4xy, because anything to the first power is just going to be itself. All right, and this last problem we are not going to do on the video, but we'll go over in class. But that is it for exponents.